Okay, our objective today is to continue going over algebraic proofs. Okay, here was your homework problem, which I know that you guys already checked. Before we do one thing with this, does anyone have questions with me on any part of your homework proof? Sure? Okay, I want you to go to the top of that paper where it says figure, if you did not already do this. I want you to sketch the horizontal number line or the x-axis. Also sketch the coordinate plane. Okay, so on your homework where it says figure, I want you to sketch the coordinate plane. John, where's your homework? You're finding it? Okay, sorry. And then the coordinate plane. Did you sketch them already? Yeah. Okay, so since we didn't have time to get to this yesterday, let's do this today. We need to illustrate your homework, which was x equals -3 on each of these. So who can tell us on this number line, what do you do to show that the only possible solution is -3? Janelle? Good. Filled in circle or dot above -3, excuse me. That's the only answer. So filled in circle above that, that's it. You do not have arrows going in either directions because it's an equation. X equals that number. Okay. On the coordinate plane, do we have a solid or dashed line? Eric? Good. Solid line going through, going through -3. Eric, do we have to shade anything? Nope. No shading because that's the only answer. So think back to when we did this a couple of days ago. You just have a vertical line, solid, going right through -3. Okay? All right. Questions on either of those? Okay. I need you guys and girls to get a piece of proof paper, one of the blank ones, or flip over something, whatever you have. We're going to do some more practice in class today. And then ideally, I'd like to give you some time in class to start your homework so that we can walk around and help you and make sure that you guys are all on the right track and right page. Okay, so on a blank piece of paper, whether on the back or on a new one, I want you to write down number 3. Okay, this is the third proof, including the homework that we've done in class. So including the homework, this is the third proof that we've done. All right, I want you to jot down what's given, what you need to prove, and then I also want you to sketch the coordinate plane and the horizontal number line. So I also want you to sketch the coordinate plane and the number line. John, did you sketch your? Okay. And sketch your two figures here. You're so quiet today. Everyone all right? Here. Thanks, Chase. Okay, so after you have that sketched and these written down, first thing always is write down the given problem. So do not change anything. Write down exactly what is given. Okay, and don't write number 2 yet. So write down exactly what is given. Okay, I want you to think back to 2 days ago. I know fractions is probably not your favorite thing. What is the first thing I told you to do before you distribute a fraction through? Does anyone remember? It's the first thing I told you to do before you distribute a fraction through. Jess? Good job. Put everything over 1. So don't write number 2 down. I want you to put everything over 1. So put a 1 underneath the 2x and the -8. Okay, underneath that, do not write 2. Okay, I know it's the third time I said that. Let's distribute. 3/4 times 2x. When you're multiplying or distributing fractions, multiply across the top, across the bottom. 3 times 2, or 3 times 2x, however you want to think of it, is 6x. And then 4 times 1 is 4. So multiply across the top, across the bottom, you get 6x over 4. Okay, we're now distributing 3/4 to -8. 3 times -8 is -24. 4 times 1 is 4. You okay, Chase? Okay. Rewrite greater than or equal to 6. Okay, now, that's not step 2 yet because we just showed our work. I want you underneath that to write down step 2. Before we actually write down the result of our distributing, what can we do to make our life a little bit easier on this inequality? Do you know? Awesome. Reduce this fraction. We were talking about this one, right? Okay, good. Reduce this fraction right here. We did this once a couple days ago. So leave this alone. Negative 24 divided by 4 is going to become negative 6. Now you might be asking yourself, why is she making us do this in 2 steps? I'm just having you show your work for now so that you remember when you're distributing here, if this fraction ends up turning out nicely, rewrite it so that it's an integer for you. It'll save you some time. John? Yeah. You could change this to 3/2 or 1.5. I'm going to leave it like this because it's good practice like this, but you could. If you disagree with me, you'd rather simplify, go ahead. Okay? Anyone else? Questions or comments? Okay, so 6x over 4 minus 6 greater than or equal to 6 is step 2. And again, above that, that's just our work. That's so that you know, okay, we distributed the fraction, then we simplified. What property did we use to get from here to here? So in other words, what's our justification? What's our reason? I should have more than Chase. What's our justification? What's our reason? Ben, what do you think? Distributive what? Good. Distributive property. Does anyone remember, and this might be a long stretch here, anyone remember why it's just distributive property and not property of inequality? Bless you. Does anyone remember? Why is it just distributive property and not property of inequality? Chase? No? Nice try, though. Anyone else have an idea? Okay, here's why it's only distributive property. We only distributed on one side of the inequality, not on both. If you only do something on one side, you just use distributive property or addition property. If you only do it on one side of the okay? All right. Step 3. Carly, what would you do next if we were just solving this normally? Good job. So now we need to add 6 to both sides. It's going to cancel here. We're left with 6x over 4 greater than or equal to 12. Daniela, what is the justification or reason that we got from how we got from step 2 to step 3? Good job. Addition, property of inequality. And for now, I'd prefer that you write it all out. So addition, property of inequality. Here's why. We added the same thing to both sides of the inequality, plus 6, and then it's an inequality, which is why it's of inequality and not of equality. So addition, property of inequality. Okay, do it on both sides. It has to say of equality or of inequality. Anyone need me to clarify anything further on that? Okay. All right, next step. Angela, just solving normally, what would you get rid of next? Not multiplied by what? Not multiplied by 6. Is that are you telling me to multiply both sides by 6? Yeah. Multiplied by what? Nope. That's okay. Yeah. Do you know why for? Good. Okay. Good. So what you want to do now? We need to get rid of that fraction somehow. Fractions are a pain, right? The easiest way for you to get rid of it is take the bottom of the fraction, multiply both sides by the denominator. Does that make sense? Okay, so these are going to cancel. Please make sure that you cancel these. They go away. Okay, we end up with 6x greater than or equal to 48. Kate, what is the property that allowed us to do that? To go from here to here. Good. So multiplication, property of inequality. Sorry, these are so messy. Multiplication, property of inequality. Okay, and then Brandon, what's the last thing that we need to do? Good job. Good job. Get rid of the 6. We always need to get the variable by itself. So we have x is greater than or equal to 8. Eric, what is the property that allowed us to do that? Good. Division, property of inequality. So division property of inequality. Why is it of inequality? We divided 6 on both sides, and this is an inequality, not an equation. Okay, we're done with the proof. Anyone have questions on any part of the proof? Okay, let's illustrate it on the number line. Okay, so greater than or equal to, Lauren, do we have an open or closed circle if it's greater than or equal to? Greater than or equal to? You okay? You know why? Do you remember why it's closed? Not really? Okay, anyone remember, Kate? Good. It can be equal to 8. So greater than or equal to, so it could be greater than 8, but it can also be equal to 8. So you color it in because it can be 8 or it can be more. Greater than or equal to means arrow needs to go to the right. So color it in, fill it in, greater than or equal to, go into the right. Everyone okay with that? Okay, Chase, you okay? Okay, I didn't know if you had your hand up. Bless you. Okay, Chase, solid or dashed line? Good. Solid line going through 8. Chase, why is it solid and not dashed? Good. It can be equal to 8, so it has to be, bless you. You okay? Solid line going through 8. Because it can be equal to 8, it could also be greater. So you're shading, if you didn't already shade, you're shading to the right. Chase, is your hand like that because you have a question? Or are you resting your head? Okay. Any questions or comments on any part of that? All you sleepy people out there. We okay? All right, let's do 2 more together, okay? Hopefully you guys aren't completely bored by the end of this. Is this really, really easy for you? Okay, so that's why some of you guys are just sitting there with blank stares maybe. And I'm sure you're tired. All right, number 4, but it's the second one we're doing today. So flip over to find yourself a blank sheet of proof paper. This one is much shorter and I think a little bit easier than the one we just did. But you can tell me what you think when we're done. So x over 7 plus 3 equals negative 2 is what we're given. And then we need to prove x equals negative 35. So x over 7 plus 3 equals negative 2. We need to prove x equals negative 35. And then on your, where it says figure, sketch the coordinate plane and the x-axis. So where it says figure, just for now, sketch your coordinate plane and horizontal number line. Sketch your planes first, please. Okay, so step 1, always write down exactly what is given. So we have x over 7 plus 3 equals negative 2. Write down exactly what is given, and it's always, your reason or justification is always given. All right, John, what's the second thing we need to do? Okay, don't need to do that. There's nothing wrong with doing that, but you don't need to do that. Go ahead, John. Where are the tissues at? I threw a box over there. I just opened a new one. Okay. Corinne. Good. It's like a 2-step equation. So minus 3 on both sides. Again, underneath the number, show your work. This goes away. We're left with x over 7 equals negative 2 minus 3 is negative 5. John, do you see that step? Like, okay. So minus 3, you end up with negative 5 on the right-hand side. Celine, what is the property that allowed us to do that? Good. Subtraction. Celine, property of what? Good job. Property of equality this time. Besides Celine, who can tell us why is it of equality on this one? Do you know? Good. You did both sides. And what's the other reason, Janelle? Equality. Good job. Equality is when there's an equal sign or when it's an equation. Inequality is when it's greater than, less than, any of those symbols. Okay? All right, Kate, next part. Good. So this is the part where you need to take the denominator or bottom of the fraction and get rid of it. multiply both sides by the bottom of the fraction. Okay, get rid of it. We're left with x equals negative 35, which is what we had to prove. We had to show that x was equal to negative 35. Liz, how did we get to that, or what property did we use? Good job. Multiplication property of, did you say equality or inequality? Good job. Equality, just making sure I heard you right. Of equality. Remember, you multiplied on both sides, and it's an equation. So multiplication property of equality. Angela. Okay, I'll explain it again. Thank you for asking. So easiest way to do that, Angela, is if there's an equal sign in your original problem and throughout the proof, you're using equality because that means it's an equation. If it's greater than, less than, greater than, equal to, in what you're given, then it has to be of inequality because it's an inequality sign, or it actually is an inequality. Does that make it a little more clear? Sure. Anyone else? Okay, so let's graph these where it says figure on your, which you guys should already have graphed. On the horizontal line, let me start with negative 36, negative 35, negative 34. So it's x equals negative 35. Zach, do we have a filled in or open circle? Good, filled in circle. Zach, do we need a line going in either direction? No, there's one possible solution, which is negative 35, so keep it like that. I'm going to count by tens on the coordinate plane. Jake, do we have a solid or dashed line going through negative 35? Good, solid line. Jake, do we need to color anything? No, no shading, solid line going through negative 35. That's it. Questions on that one? Okay, one more I want to do, so find one more paper, one more page of blank proof paper. Now this one, we're going to incorporate a property that we have not used yet in a proof, but we did discuss yesterday. So don't go ahead of me on this one, please. I know some of you guys like to go ahead of me, but not on this one. Okay, so we have x is less than negative 4, and then inside parentheses, 1 plus x. 8 is less than negative 4, in parentheses, 1 plus x. We need to prove that x is less than negative 3. And then I need you to make sure where it says figure, just sketch the number line and the coordinate plane so that we're all organized. Just sketch your coordinate plane and number line. John, you were okay with the last one, right? With the steps? Okay. All right, so first thing we want to do, let's do this first. Write down what's given the exact way that it shows in the problem. So please make sure you write down the given just as it appears. Some people in second period made some silly mistakes with that. So write down the given just as it looks. The justification or reason is always given. Okay, don't go ahead. In our note packet, when we see a problem like this, whether it's an equation or an inequality, what do I always try to have you guys do first? Always, in a problem like this. Tori? Good. I want you guys to we're going to take this whole thing. If I could pick this up and flip it around, that's exactly what we're doing. We're taking this whole thing, picking it up, and we're flipping it around. Okay, so step 2, we're going to move negative 4, 1 plus x to the left-hand side. Move 8 to the right-hand side. And then less than is going to change to what? Greater than. So actually flip that around too. Okay? So move everything to the opposite side. It's like you're picking it up and flipping it over so that x is on the left. All right, without looking at your properties, does anyone remember? Good. What is the property? Anyone else? Here's a hint for those of you that are just sitting there. It begins with an S. Anyone else think of it? Sorry, was it not what you had? Good, symmetric. So it is the symmetric property of what? Good job. Symmetric property of inequality, if you can read that. Symmetric property of inequality. So when you're flipping things, you're flipping it on both sides because you're flipping the whole thing around. So it's symmetric, but it's also property of equality or inequality because you're doing it on both sides. You're changing both sides. Okay? Do not flip in step 1. Write the given down and then flip. Okay, that was a mistake that we saw earlier this morning. Okay, is everyone all right? Symmetric property of inequality in my messy writing here. All right, now what? Brandon, what would you do next? Good, distribute. You all right over there? Negative 4 times 1 is negative 4. Negative 4 times x is negative 4x. Just simply multiplying negative 4 through. Rewrite greater than 8. Amber, what property did we use to get from step 2 to step 3? Good job. Distributive property. Amber, why is it just property and not of inequality? Okay, that's all right. Chase, do you remember? Good. We only are distributing on one side, so it's distributive property, okay, because we're only doing it on one side of the inequality. Zach, can you see okay? All right, next step, 4. Carly, what's the next thing you would do? Good. We're now down to a 2-step inequality. So add 4 to both sides. It's going to cancel on the left. We're left with negative 4x greater than 12. So negative 4x greater than 12. And justification for that, Jake, is what? Good job. Oh, wait. Addition property of what? Good. Why is it inequality and not equality? Good job. Since it's greater than, addition property of inequality, not equality. Okay? All right, last step. I'll let someone volunteer here. There's 2 things that are going to happen for us to prove what we need to. So what's going to happen between step 4 and 5? One more time. What's going to happen between step 4 and 5? I know a lot of you know this. Liz, what do you think? Awesome. Why do you switch the sign, Liz? Good job. So we need to divide both sides by negative 4. Please remember, if you multiply or divide both sides by a negative, the inequality sign is going to flip or reverse. So this becomes x greater than changes to less than. 12 divided by negative 4 is negative 3. So we proved x is less than negative 3. Our justification here is division property of inequality. Division property of inequality. Okay, so that's it for the proof. Before we do the figures, does anyone have a question on why we used anything that we did on this or how we solved it? Okay, still easy for you? All right, let's go to the figure. X is less than negative 3. Corinne, what kind of circle do we have above negative 3? Good job. Open circle above negative 3. Sabrina, is the arrow going to the left or to the right? Good. Going to the left because it's less than. On the coordinate plane, Chase, solid or dashed line? Good. Then are we coloring to the left or to the right? Good. Less than, so shade or color to the left. Remember, that shaded region is really going to go on forever, all the way to negative infinity. I just don't want to color the whole smartboard. Chase. Good question. Good question. It could be negative 3.1. It could be negative 3.9. So you got to make sure that you're including the decimals in here. It's not just a whole number or integer. It could also be the decimals in between. Great question, though. Anyone else? Okay, you're going to need 3 blank sides of proof paper. We have about 12 minutes, so here's what I want you to do. Besides your corrections for simplifying radicals, you have 3 homework problems, okay? The first one, and you might want to write this on one of the blank proof papers. You are given an equation, 27 equals 2x plus 3 in front of parentheses and then x plus 4. You need to prove x equals 3. And then I won't read the second and third one because you guys are all in different spots. Second and third one are up here. I would make sure you have these written down before you actually start proving them. So we're going to check homework tomorrow. The 3 of these proofs are due. And then your simplifying radicals corrections must be turned in tomorrow, obviously if you're here today, to get full credit or for us to regrade them, depending on what happens when you redo them. Okay? Any questions ever, please come in during homeroom anytime from when you get here until 8 o'clock because one of us will not be teaching, so one of us can help you. Okay? Okay, I'm just going to stop this recording, so give me 1 second here.